Now, what's important to know for this kind of product is that fibers have two parts. One, the fiber. Fiber means it's just kind of a plastic wire that guides light, which is this here. And then you have a little amplifier, which is this product here. Maybe I can show it to you here physically. I will do my best so you can see it. Now, okay, here you can see. So it gives you an idea. That's the size of the amplifier. And this here are this kind of plastic wires that guides light. And then at the air point, you have the light comes out. That's a fiber, and that's an amplifier. And of these kind of fibers, we have a lot of fibers with different heads. Means, for example, this one here is relatively big, as you can see here. And then you have really tiny ones, which are the point of a needle. Looks like this. So I think you can see it here, pretty small. Then you have special ones with a lens on top to see really small objects. So there are 270 models around that we have. And basically the amplifier has two sides. One is the one where the light is guided. It comes out here, and here's a flash who points where the light comes back and is measured. So light output, light input. And on the other side, you connect an electrical cable where you can receive and send signals. So that's the basics of the amplifier. And then on the amplifier itself, you have some buttons and some indicators. One indication, for example, here now it's set to 2000. This is the limit value, means, or here's the actual value. This actual value indicates the quantity of light that the sensor can see. 0, no light. 4000 is lots of light. So here's something in between. And here you can set a limit with the push buttons on the right side of the amplifier. And here is set to 2000, means when the value, the actual value is higher than 2000, you have one status. And if it's lower than 2000, you have another status. And for the fibers, I just said, we have lots of different ones. Some have a sender where light comes out on one side, and the other side is the receiver where the light comes back and is measured. It can be something like this, like a curtain. So light comes out here, it's a bit interrupted, so he receives less light. So it doesn't mean light on, off, it measures really the quantity. And here you see one, you have the light comes out and is measured in the same head. This works also. And then you have some USPs. These are the points which are important for the sales engineers. So to find the arguments why the customer should buy this product and why is it good for a certain application. So here, for example, you have chemical resistance fibers. You have fibers who are resistant to high temperature, up to 350 degrees. If you have lots of amplifiers placed close one to the other, you can copy the settings you have done via an infrared copy function. Then it's important that you can band very tight the fiber. And if it's fixed on a robot, the robot moves the whole day with the fiber. They have to be sure that the fiber doesn't break. So we can guarantee that 10 million times the fiber can be banded. And then we have a fiber book. This is good for the sales team and for the customer. They can really find in this book what fiber is the best for their application. Because with 270 fibers, it's not easy to find the correct one, but this book is really helpful. So now you have seen basically we have fibers, so these little plastic wires that guides light. We measure the light and we have an amplifier. So now I'll show you a bit how does this whole thing works. I took as an example a beer bottle, and we consider it a beer bottle correct, capped, maybe that's the right word, where the cover is placed correctly. And sometimes the machine places two caps, and which is not correct. So the target for this application is to make the difference. Is it a bottle that can be sent to the customer, to the supermarket, or shall it be separated from all the good bottles so they can be readjusted manually or whatever? But the sensor needs to see the difference. And here you can, here's an example. So the sensor sends light, it's like kind of a lamp, over the cap, and the receiver can see the light. So if it's a cap which is conform, so correct, a good bottle, you see a certain quantity of light which is relatively high. So if the cap looks like this, there's less light received. And you can now, based on the quantity of light, know if the bottle is, if it's this one or if it's that one. So here's light visible, here's no light or less light. So that's basically how does it work for a sensor. So here, the application, here is light sent. You see the flash, it sends light out. There can be a little lens, so the light is focused. It goes over the bottle to the receiver, and then it is received. That's the basic part. If it's the first bottle, you have maybe this value. For the next bottle, the value is different because not all bottles are 100% identical. But you can notice that each bottle, if it's a good one, gives a value over 3,000. So now we have a limit 3,000 for good bottles. And then now we have a bottle where the cap is, there are two caps on it. So again, light is sent. There is not this much light received, and it gives a lower value. Let's say 323, for example, or 800 or 400. So every time it's less than 1,000. So we can say a good bottle always over 3,000, bad bottles lower than 1,000. So we just defined a limit of 2,000. 2,000 is the limit who says lower than 2,000, bad bottle, higher, good bottle. And the whole application is set up now like this. Here you see the limit value that is set with the little buttons. This is the actual value for this kind of bottle. And when I have this bottle, limit the same. The actual value is much lower. And when it's lower than 2,000, I can define that I have here a little signal, which is not on here, but it goes on here. And this signal shows, okay, that's a bottle which is not conform. And this is just an indicator on the amplifier, but of course it sends an electrical signal here out on the other side. And this electrical signal can now go to the robot or to the machine and act. For example, generate an actor who kicks out or he moves the bottle to another chain. Now I try to show this in the practical way. It's like this, the bottle comes, passes on a converter belt in front of this sensor, and I have always a value which is now above 2,000. So this is a bottle okay. And now I have a bottle which is not okay. Say principle, lower value. So bottle NG means not good. Of course, in reality, bottles don't move this slow. In reality, bottles move in beer productions 20 bottles a second. That's about a real normal speed in production lines. So every 20 bottles per second. So, but each bottle needs to be checked, identified, and selected. So in high speed, it looks a bit like this. So this is pretty fast. Every time a good bottle passes, it goes through the conveyor belt. And if it's not good, it's selected. It's moved, like you see here now, to another place. This is not easy to do in a real production, but they do it. And it's a real application which has been done. So this was short, but it gives you a good idea how this basically works. And before finishing, I go to back to my screen. How does this work? Just for you to show, here you can see the amplifier. I assume that you can see also the value. Here you see the fiber. You see it's pretty small, and there's light. Here's the other side. And if you put one in front of the other, you should see here now the value goes up to 4,000. And if I am not in front or I put my fingers in front, the value is 0. And I have a limit of, I think it's 300, yeah, 320. So as soon as the value is bigger than 320, the little light goes on and indicates that there is an electric signal to identify a product which is not conform, too big, too high. And of course, the bottles is just one example. You can check syringes or any product which is on your table, pans in a production line, your glass in a production line, your keyboard, the plastic parts of your mouse. Everything what's in a production line needs to be checked if it's conform. And to do so, optical sensors can be a solution. Okay, now you have seen the basics, what optical sensors can do, especially the fibers. And I will give the word to Andre Kirchhofer, who will now explain how these little things really work, because it's not only the limit you can set, you can do many other things, but I showed you just the basics. And Andre Kirchhofer will show you now more in detail how does it work. So if you are interested, just stay. And if it's enough for you and you know now what a sensor is for, I thank you for your participation. Okay, Andre, I give you the word. It's your turn.
Then, good morning, everybody, from my side. I will start now the technical part of the skill session, the basic introduction of this FX500 series. And I divided my agenda into 3 main parts. First of all, basic information. There will provide an overview of the basic features and highlight some interesting product properties. The second part will be the communication area of this product. There we'll focus on the IO-Link type of the FX500 series. And I will demonstrate how intelligent the sensor works with our Ethernet-based PLCs. The third part is the demonstration part. There I will practically demonstrate the product, and my task is to give you an idea of the sensor's functions and from practical perspective. First, regarding product concept and features, in this FX500 series, we have 3 main types, let me say. The first type, FX500, is good for when the need of high-speed response and precise detection is necessary. Then the FX500 has a maximum response time about 40 kilohertz or 25 microseconds. So when you need high speed or when you have high-speed applications, then this sensor is a very good choice. Second part is the FX550 series. This is the so-called high emission type for applications which requires higher emission power or more stable reflection. This FX550 is very good. It offers, compared to the FX500, 3 times higher emission power and also a longer sensing range compared to FX500. I think maximum is up to 3.5 meters. Then when there's a need of advanced communication features or self-diagnosis capabilities, the so-called IO-Link type of the sensor series makes a lot of sense, because with this IO-Link compatible, you have a suitable sensor for smart factory environments, and you can provide high-level self-diagnosis functions. As Patrick mentioned before, the amplifier is the main part of this product concept. In this picture, you can see on the right side the interface. There you connect, for example, the power supply, the inputs and outputs, or also the IO-Link interface. On the left side, you can see here the so-called, there you can connect the so-called fiber heads. And the fiber heads are equipped with two fiber optic cables. One cable is connected to the emitter side, and one cable is connected to the receiver part of the amplifier. This you can see here in the picture, mentioned with these two arrows. The bottom arrow here, you can see this is the receiver part, it's the incoming arrow, and the outgoing arrow is the transmitter or emitter part of this amplifier. Then, as I told you, fast response time, up to 25 microseconds. We have also here on the top of the amplifier some push buttons to make a simple execution of settings which are divided into several pro modes. Each pro mode has a, let me say, a function or a unique function which is which can be set there. If IO-Link interface is integrated, then every setting and every let me say every parameter you do in the pro modes, you can do via, for example, via PLC and PLC commands. And when you have some, for example, in the testing phase, you can also use a configuration tool, which is free of charge. There you can connect the amplifier in your application and test, let me say, the first settings of which are necessary to, like Patrick mentioned, for example, to check the caps of bottles. Very important from application side of view is the response time. So that means how the amount of time which a sensor takes to react to a change of its input signal. In context of fiber amplifiers, it is the time taken for the amplifier to detect a change in the light signal and produce an output signal accordingly. For example, if a fiber amplifier has a response time of 100 milliseconds, it means that the amplifier can detect and respond to changes in the light signal within 100 microseconds. Also important is also important parameter of the specification is the sensing range. Also, when we talk about fiber amplifiers, it is the distance over which the amplifier can detect the presence or absence of an object using the light signal transmitted through the fiber head cables. For example, when we have a sensing range up to 1 meter, then the sensor is able to detect an object 1 meter away from the sensing point, which starts from the outcoming light of the sensor of the fiber head. Teaching is a function which is possible with the amplifier. What does it mean? The amplifier can set its threshold value using this kind of teaching function. You can see here in the picture an example where a wire interrupts the light signal a little bit, and this produces a special light amount value at the amplifier. This value can more or less be stored through this teaching function in the amplifier, and this established a so-called threshold value. And then whenever this wire interrupts the light signal as shown in the picture here, the digital output changes its state because of the threshold value is now let me say, exceeded, and then the output of the amplifier switches from on to off or from off to on, depends on what you have set. Then also a very interesting function is the so-called threshold tracking function. The amplifier automatically adjusts the threshold value by monitoring the incident light intensity at specified intervals. That means this function helps the amplifier adapt to changes in the environment, such as dust accumulation over a long period. You can see here in the picture the current value or the light intensity shrink or decreases, and the amplifier automatically adapted the threshold value here. And this continuously updating of the threshold value has the advantage that the amplifier maintains accurate detection and reduces the need of frequent manual adjustments and maintenance. So very good, let me say, function in area of, let me say, preventive maintenance and so on. Some amplifiers has also an analog output. You can see here in the picture the relationship between the light intensity value from 0 to 4000, for example, and the analog value on the y-axis here. It's a linear relationship. That means when the value increases, the light intensity value, the current output of the sensor also increases. For example, here, if you have a value of 0, then the analog current is 4 milliamps. And in the maximum, you have, for example, 4000 at the light intensity side, then 20 milliamps is the current at the analog output.
Andre, one question.
Yeah.
Why
Sure.
is it marked 8000? I didn't know that an amplifier offers a high Doppler resolution. It's only up to 4000. Here it's marked 8. Is there one who can show 8000?
Yeah, it depends on the setting of the sampling time. So you can set to standard or hyper mode, for example, and then this value can be 4000 or 8000, or the maximum is 9999.
Okay.
So that means when the higher the value here, so the more sensitive your reaction of the light intensity value is, you can say.
Thank you.
Yeah, and you have also when let me say when this value is higher, you have a higher resolution. For example, yeah, I think you understand, because you have more values from 4 to 20 milliamps than with 4000, for example.
Yeah, if you have more little steps.
More little steps, right? Yeah. Also, interesting function is the optical communication function. You can see here in the picture a small window, which is at the side of the amplifier. And when you connect several amplifiers to each other, then this window, you can see, you can say it goes from here up to the end. And when let me say a parameter, or when a data or parameter is set, it can be directly copied to all amplifiers if needed, or you can also save all settings all at once with one command. So interesting if you have machines with several amplifiers with several measurement or with several detection points, and all have more or less to do the same settings. You can then directly set all the parameters to all amplifiers with one command, for example. Which comes with there's also some possibility to connect the amplifiers to networks. In this case, we can connect to CC-Link and Ethercat networks. Therefore, a so-called open network communication unit is necessary. This is the so-called SCGU3 series here. This is this part. And on the right side here, you can connect our FX500 amplifiers. I think up to 15 per let me say per open network unit, and then it's possible to connect, for example, to a Ethercat network or a CC-Link network, and all settings, parameters, settings, and also the monitoring can be done via PLC or a higher controlling part like PLC, PC or something like that. So interesting to know this is an option for this amplifiers, which can be sold separately. And you can see here also, this is not only for the fiber amplifiers interesting, also for some laser sensor amplifiers, LS series, and for some pressure sensor series DPS, you can use this network communication units. Yeah, from application side of view, high-speed scanning, if you need high-speed scanning, for example, counting of bottles, then the FX500 series is very good because of this very fast response time, 40 kilohertz. If you need some surface detection or some differentiation of surfaces, for example, here you have boxes and they're coming, for example, with white or black or whatever labels on it. The sensor is able, or the fiber is able to detect this label on the boxes.
Maybe you should add. Excuse me.
Yeah.
Can you go back? Maybe you should add. It can detect the boxes, the labels on the
Yeah.
box. If the
Yeah.
label is white, for example, and the box is gray, so
Yeah.
it
So there must be
reflects
a
more light because it's white. And if you have more light, the value increases, and you set the limit to white labels, for
correct.
example. Ah, yeah.
Yeah. Yeah. Correct. So, for example, it will not work if the package is white and the label is white.
Yeah.
So there must be a
contrast.
Yeah, a difference between the contrast. Yeah, a difference between the surfaces. Yeah, which then gives the opportunity to have two different light amounts, and this can be detected then.
Mm-hmm.
Also interesting, I think, is the white beam fiber type. For example, here in this picture with this wire, this is a so-called it's a kind of, what do you say, kind of curtains, right?
Mm-hmm.
And I think we have 10 millimeter and 32 millimeter widths, where you can, for example, check also shapes. For example, in this example, the shape or the length of a screw or a screw head. If you want to do some application, in this case, detection or inspection of heads from different screws can be a possible application with this wide beam fiber. Okay, second part, the communication with IO-Link. How does this work in detail? For example, here, this is more or less like an industry network is looking at the moment. You have here controller levels and then on the second level side, you have so-called field or bus levels, which are, let me say, collecting all data from the so-called sensor level. In our case, we can connect our fiber amplifier via an IO-Link master unit to an field bus field bus network, and then we are able to have an interface, or this is now an interface to the PLC, which can be then have the advantage that we can do remote setting of parameters from the PLC or from a higher controller level, and all data can be monitored in the controller level, and also all data can be logged, for example, for traceability functions and so on. It's very important that the data can be stored for later analysis, for example. When we connect the sensor to our, let me say, to our IO-Link master, or to an IO-Link master, there we have a so-called configuration software. And I will show you in the next slide a little bit how this works. You can see here, this is a camera picture of an fiber head, which is, let me say, emitting light to a black surface. And on the right side, you can see the configuration tool, so-called IO-Link configuration tool. And now with this tool, I can, for example, set parameters and so on. Therefore, I need to have a small IO-Link master unit, which I will connect to the software. And to this master unit, the amplifier is connected. You can see here. Then I double click and I have directly an overview about the important parameters, light intensity value, if the sensor is emission light, control output, if there's some notification, some error. I can directly read all parameters out of the amplifier. Diagnosis, I can see operating time of the amplifier. In the setting area, I have a lot of setting possibilities. And I will show you how the so-called teaching function is working. You can see here 2-point teaching. That means I want to teach the background and the product to get a, let me say, to get a dedicated or related threshold value. You can see here with the product, the light intensity goes up to 2000. Then I teach, and this will, let me say, will set the threshold value, which is between 115 and 2000. And then now, every time the object comes, the control output goes to on.
How did you teach? Do you click here on the software, or was it on the hardware?
I click in the software. I click in the software.
Okay.
Very easy. Also, a good feature is in the when you have or when you can monitor the analog or the value. You can see here the value increases, the output goes on, the output goes off when the value decreases. Now you can see here a black part, and it's a little bit recognized, but the output is not affected because the threshold is not would not be exceeded. Then also some, let me say, some standard things is possible to do. For example, you can stop the emission. You can see. Okay. That was the wrong button. Yeah. Emission goes off, for example. Then light intensity is 0. Emission goes on. And the light goes on. There are also additional settings. You have also the possibility with the software to make a restore to factory settings. and a lot of more. But this software is more or less a helping or a tool to help you to get in testing phase of your application to get let me say to get a picture of if the amplifier or if the sensor itself can detect this product or not, and make some quick adjustments and some diagnosis during let me say processing speed or something like that. But in real, for example, it looks more like this. You have or let me say, to get a clearer picture what is possible in context with our PLC portfolio, there's a lot of possibilities you can see here. We can connect our sensor via IO-Link field bus gateway to our whole portfolio of Ethernet-based PLCs. And this can be, then we can also connect our, let me say, our HMIs, HM panels, or FPI4C as communicator. And this opens also a gateway to the Covina platform. And also, I don't mention it here, you can connect here SQL databases, for example, where you can log your data, or you can save your data there, save your parameters there for the sensor field level. Yeah, and it's also very easy to integrate in existing projects, and all configuration can now be done in the HM panel, for example, or in the PLC, let me say, and remote controlling all over the world with the gateway to Covina is possible. So if the machine is in, let me say, is in Indonesia, and the maintenance operator is in UK, then with Covina platform you have the possibility to connect to this machine and change parameters, or can do some fault inspection and so on. One example I will show you more in detail. I connect the FX series to our let me say to an IO-Link master, and on this side here we have Modbus TCP communication. This can be handled by our FP0H, and this is then also connected to the HM panel. In the PLC, I have some let me say function blocks. In this example, the process data function blocks, which is for cyclic communication with the sensor. So let me say you have a cyclic request to the sensor, and the sensor makes a cyclic respond to the PLC, and this goes more or less nearly real time. So sensor gets a question and it answers with the parameters, for example, to the PLC. And this can be then here monitored with this function block. You have the intensity value, output state, how the emission is true, and some error indication can be requested with this function block. On the other side, you have then the HM panel, which is connected to our PLC. We can monitor measurement values, setting all parameters of the sensor, get the whole status of the sensor outputs, for example, and also get the diagnosis feedback of the amplifier. This I show you here. I have also the same fiber head on the left side, and now this is connected to a real network. The fiber amplifier to the IO-Link master, Modbus TCP on this controller level side. Then I switch to the page where the parameters can be set. You can now see here the actual light intensity from the black surface. At the moment, there's a limit. With this value, the output is at the moment on. I can also here have a lot of monitoring. That is only some values. There are a lot of more. And now if I want to change the output functionality, for example, I can switch to light on. Then it means if this limit is over, or dark on. So I can change the state of the output and the reaction to the limit, let me say. With the limit, I can also make a manual limit here, 2500. That means when the value exceeded 2500, then the output goes to on. This happens when I, for example, change the surface here, or when I put an object into the light. In this case, a very shiny object, the aluminum part. So you can see here the light intensity goes up to 3800, and the limit is it's more than the limit, and this is then that the output switches on. I can also do this kind of teaching here. I teach my part with the first teach button. Then I teach the background with the second teach button. And then the limit is, or the threshold value is adapted. You can see here it's now 2005. So every time when the light intensity goes over 2005, then the output goes on. Now I change to a black part, I think. Then the value is, you can see here, the value a little bit increases, but not too much. So in this case, the sensor is able to differentiate between black part and the very shiny part. Also interesting is with our HM panel, we have also the possibility to get a real-time trend here of the measured value. Or we can make a little bit animation here when the object goes nearer to the head or goes more far away. You can see here a little bit moving. But only this is only let me say not all functionalities, but a lot of. For example, or let me say in conclusion, it's what we can do with this kind of network or with our products. We can transmit precise data to our PLC, and this allows an immediate processing and response. Through IO-Link, all amplifier configuration parameters can be set and monitored in nearly real time, let me say. We can integrate directly or in existing automation systems to optimize processes. Yeah, and the sensor is able to to recognize, let me say, mail functions and so on. So we can detect maintenance needs very quickly and minimize then downtime of the machine, for example. Okay. So if you need additional information, we have our sensor info hub. There you can download a lot of things and to get all, for example, all manuals there. And in future or in the next weeks and months, there are coming the so-called IO-Link quick start guides to with the PLC example projects in the info hub, which can be downloaded by you or by our customers if they want to do or if they want to have some example application with our products. Then if you need more detailed training in, for example, in this FX500 series or in this FX500 IO-Link series, then we offer a lot of trainings in the Panasonic Academy, as you know. And there are also some videos about the FX500 series in the Panasonic channel in YouTube. Yeah, okay. The presentation is over.
Panasonic Industry.